Hey guys, we're going to do stats 5 and 6 review. So this is what it looks like in Canvas. And I'm posting these videos now. Now remember, the link you can see the odd, and on the video you can see all of them, not just the odd and the even and the explanations. Remember, we're making sure, even though we're doing multiple choice questions, that we're writing out our explanations or else we won't receive credit. So let's do it. Question number 1 in section 5. Says in the fall of her senior year, Carrie had begun to submit college applications. Based on her research, she estimated the probability of her being admitted to the University of Georgia as, so she's either going to get into Georgia or not get into Georgia, right? And essentially she's saying that that's 45 out of 100. And her admitted to both the University of Georgia and Auburn as 25%. So she's either going to get into Auburn or not get into Auburn. So this idea of both, right, would fit right there, Auburn and Georgia. And I can use a decimal here, or I can make it regular numbers. It's just personal preference. It does not matter. But I tend to make them actual numbers, so I think of them as chances or actual people or something like that. And their probability of not being admitted to either one would be 10 out of 100, or 0.1. Now, if her assumption is correct, what is the probability of being admitted to Auburn? So what are they asking in the question? They're asking what goes here. So using the complement rule, I can fill in the other items. The red items, what's given in the problem, and the other items given from the complement rule. So that would be that, right? And that's going to be 65. Or, no, I don't know how to add. Sorry. 70. And there's my answer there, right? Now, let's say that technique doesn't really jive with you. That seems a little awkward. You're not sure about that. What would be another method? And we could, some scholars, mathematicians, students like the Venn diagram. So again, they're thinking admitted to University of Georgia is 0.45 and Auburn is 0.25, or the number, not as a decimal. You could show those as a number. Admitted to neither is 0.10, right? And, oh wait, I just filled that out wrong. Sorry. Saying admitted to both was 0.25. Now again, using the complement rule, that's how we come up with that, because we know that those two numbers have to add up to 45. And we know that all 4 slots have to add up to 1. So we can put an X here and kind of solve for that, right? So 1 take away 10 is 90. Take away the 45, and we get 45. So we know this would have to be 0.45. Now, can we figure out what's the probability of Auburn? Yes, 0.7. So 2 ways to do the same problem. Question number 2. A recent survey of employees at Artvertic Enterprises concerned their attitudes toward their healthcare reform produced the following results. So it looks like there were only 2 types of employees, assembly line and administrative, and you're either in favor, opposed, or don't have an opinion. So first and foremost, there's something missing here, right? We need our subtotals in order to calculate probabilities here. So I'm just going to fill these in, even though I don't know what they're asking. That's usually something I'm going to need. And so that would be 140, right? And then if I look at that, that would be 111 plus 140, 150. Yeah. All right, now considering only employees who were opposed. So forgetting about everyone else and just thinking about these 73 employees, considering only the employees who opposed the healthcare, what is the probability that a randomly selected worker is on the administrative staff? So that's the 31 out of 73. And we find our answer right there. Nice work. 3, the grade level breakdown at Byron's High School is as follows: freshman, sophomore, junior, senior. If a student at this school is selected at random, what is the probability that the student is either a junior or a senior? So that means you're not picky. This is a junior or a senior, and this is also a junior or a senior. So because they're mutual events, you can't be a junior and a senior at the same time. We have to put that label on you, one or the other. We can add them together. So the probability of A or B is equal to the probability of A plus the probability of B. Take away the intersection, or probability of A and B. Notice you can't be both a junior and a senior, so this is 0. So I'm totally okay with adding these. And I think that makes sense, right? So I get 41%, and there is my answer. Let's look at 4. If the probability of A is 3 and the probability of B is 4, and the probability of not A and not B is 4. Okay. So I, again, am kind of a two-way table gal. So I have a probability of A and not A. Remember that notation? And this is B and not B. So they're saying that the probability of A is 0.3, right? And the probability of B is 0.4. And the probability of not A and not B is 42. So this is where these items go in my table. And I can show these as decimals or as actual numbers and put my grand total as 1 or as 100, right? So if I look at that here, I know this is 0.6 using my complement rule, and then this would be 18 using the complement rule. This would be 0.70 using the complement rule. 22, no, 12. And, right? So let's see what they're asking of us. It looks like they didn't ask us anything. They're just saying, are they independent events? Well, our answer here is D. They're not disjoint and they're independent. So let's make sure we write out what each of these definitions mean. Since not P and not A is 0.42, then notice we find out that the probability of A or B would be equal to 0.58. So what do I mean by that? Meaning A or B would be the summation of these. Right? And using that addition rule, again, this would just be another way to figure this out. We know that the probability of A and B is not 0. It's actually 0.12. We figured this number out, right? So what that means is that since the probability of A and B is not 0, then A and B are not disjoint. Meaning can't happen at the same time. All right, and since we see that the probability of A times the probability of B, remember we can multiply these, and if in that fact that's the same, so let's go ahead and multiply those because that's something we haven't done here. So the probability of A we have is this, right? And the probability of B is that, or I mean vice versa, right? So 0.3 times 0.4, I get 0.12. Since the probability of A and B is, since we multiply them, and now we're going to look to see, is this equal to the probability of A and B, right? Well, let's see. It absolutely is. So since these are equal to one another, this means that they are independent. And that was based on a discussion we had on our cheat sheet earlier. It's independent. And if you don't believe me, you can take a look right here. This is the same as saying if they're independent, then it's just as if I substituted that there. It's as if it's the probability of A times the probability of B ends up being equal to probability of A and B. Okay. Back to our problems. Number 5, each Saturday morning, Bo practices throwing pitches to his dad. His dad estimates the probability of any one pitch being a strike is 0.6. If the pitches are independent, what is the probability that neither of Bo's next two pitches will be strikes? Okay, so since the probability of not a strike, since the probability of strike is 0.6, then we know the probability of not a strike is 0.4 using the complement rule because it's either a strike or not a strike. Now I want to see what is the chances that neither of the next two pitches are strikes. So that would be not a strike, and not a strike. And if they're independent, we should be able to multiply these. So the probability of not a strike times the probability of not a strike, 0.4 times 0.4, we get 0.16. And that's our answer. Now question 6 through 8 are referred to the same context. Suppose 8% of all adults have a particular disease. So the probability of this disease is 0.08. Also suppose that a test for this disease returns a positive result. 96% of the people who have the disease. So that means it's a positive result given that you have the disease is 0.96. Okay. It also returns a positive result for 7% or people that don't. So the probability of a positive given that you don't have the disease is 0.07. What is the probability that a randomly selected adult has the disease? So what is this asking for? It's asking for the probability that a randomly selected adult has the disease and. So it's looking for a disease and positive. Okay. Let's break this down a little bit, okay? And I think I usually like to do this with a positive. So either you have the disease or you don't have the disease, right? So you either don't have it or you do have it. That's this information we said here. So that is the disease or you don't have the disease. Sorry, I got ahead of myself. Right, that'd be 92. And I got that from the complement. Sorry about that. Okay. So this is where we got this information. We either have the disease or we do not have the disease. Now, out of the diseased people, you're either going to test positive or you're not going to test positive. So given that you have the disease, you're going to test positive 96% of the time. So that's where I got that. And 4% of the time, you won't test positive. We know we can multiply these numbers through in our tree diagram, right? So I'm either going to test positive or I'm not going to test positive if I don't have the disease. So we know that this first one, testing positive, given you don't have the disease, is 0.7, which means this would be 0.93. And we can multiply these values out. So give me just a second to kind of crunch these numbers. And this seems like a lot of time for one problem, but remember I have 3 problems on this fact scenario. So, just kind of processing what all type of information I should be able to infer, given the information provided, is probably time well spent. Okay. So it says, what's the probability that a randomly selected person tests positive? Oh, I read 7. Oh, that one I can answer. So I haven't really answered 6, but this one's easier. So what are the ones that test positive? This one tests positive, and this one tests positive at 100. So I can add those up because you can't be one at the same time as the other. So what number looks like the sum of that? And that would be this number, right? Because that would be 0.0768 plus 0.0644. Nice. Okay, so going back to question number 6, what is the probability that a randomly selected adult has the disease and tests positive? So has the disease and tests positive, well, that is this number here, C. Now we can use this same idea of theory. We know that we were able to multiply these two because of the information provided. Make sense? Okay. Now 8, if a person is selected at random, if a person is selected and given the test, and the test is positive, so now this is going to be my denominator. This is going to be my denominator. And I can think of them as people, or I can keep it as a fraction. That doesn't matter. Either way will work. So given that you tested positive, what is the probability this person actually has it? So these are the people that have it out of the people that tested positive. So I can make a fraction here, right? And it looks like about half of the people, doesn't it? So yep, E, 0.5439. Nice work, guys. Let's look at 9. The 10,000 students at Polytech were classified according to the type of program enrolled, and their degrees as follows. What is the probability that a randomly selected student is in an MS program, given that the student is not enrolled in a science? Okay, so only looking at these 840 students. So only looking at these 840 students. How did I get that? I took 6,300 plus 2,100, right? Given that you did not enroll in a science program, what is the probability that the student is in an MS program? So it looks like these are in an MS program, right? So I'm going to go ahead and crunch that. And I get 30%. And that matches D. What is the probability a randomly selected student is enrolled in math? So kind of starting out there. A random person is in math. That'd be 210 out of the 10,000. So, oh wait, but it says Math BS. So let's see, Math BS would be these folks, right? So that'd be 882 out of the 10,000. That's going to be A. Mathematics and BS. What is the probability that a randomly selected student has a BS degree or, all right, so a randomly selected student. So it seems as if our denominator is going to be 100,000 because they're not giving us a given. But I'm okay if you have a BS degree. So I'm okay with these people, or is enrolled in an engineering program. So I'm also okay with these people. So I could add these two and then subtract the overlap. I'm more of a person, I just add those 5 numbers. So adding those 5 numbers. I get 0.7550, and that's one of my choices, 0.7550. Nice. That's a nice little group. Okay, question number 12. A weighted die is rolled 100 times and the results are given. Find the estimated probability that if the same die was rolled twice, the sum would be less than 4. Okay, so it's not a fair die, which makes it a little bit more interesting. So if we think about we're going to roll it twice, then we could think about there just being 2 die exactly the same, right? So roll number 1, roll number 2. What is the sum is going to be less than 4? Okay, so I can get a 1, a 2, a 3. 1, a 2, 3. So this sum would be 2, 3, 4. 3. This sum would be 4, 4. Everything else is greater than, right? So what's the probability it would be less than 4? So what we're looking at is what is the probability we have a 1 and a 1? I'd have to add, that's this, and the probability of 1 and a 2, and the probability of a 1 and a 3, and 1 meaning the first roll, and then also a probability of a 2 and a 1. That's 2 on the first, 1 on the second, and a 2 and a 2. And then don't forget, oh, but it said less than 4. Okay, so even fewer here, right? I'm just looking for these 3. Okay, so since the in events are independent, the probability of a 1 and a 1 would just be the probability of 1 times the probability of 1. So that would be 15 out of 100 times 15 out of 100. What's the probability of a 2 and a 1? That would be 10 out of 100 times getting the 1. That's 15 out of the 100. And this one's the same. It's just written in reverse. So 15 out of 100 times 10 over 100. Then I get to add these up. So that would be 225 over 10,000 plus 150 over 10,000 plus 150 over 10,000. So in total, that 300, 525 per 100,000. So that would be D. Nice work. Right, looking at 13 and 14 for this scenario, many fire stations handle emergency calls for medical assistance as well as those requesting firefighting equipment. A particular station says the probability that an incoming call is for medical assistance, okay, is 0.85. What is the probability that it's not for medical service? So we're essentially saying it's either for medical or it is not for medical. So the complement rule would just be 1 minus 0.85. Assuming independence, the probability that exactly one of the next 2 calls will be for medical assistant. Okay. Exactly one of the next 2 calls. So that would be medical on the first and not medical on the second, or not medical on the first and medical on the second, right? That's exactly one of the next 2 calls. All right, and I should be able to add those, right? So we know the chances of medical would be 85 or 85 out of 100. And not medical. And this would be the same, it's just reverse, but it would be the same product. And we know we can add these together. So there's 2 ways to get non-medical or medical on just one of the 2 calls. So this gives me 0.1275. Of course, for both, they're the same product. So in adding them together, I get 0.255. So when I look at 14, I find my answer is B. That matches 0.255. Last one. When we say that a coin is fair, what do we mean? Okay, well, I can tell you what I mean without picking these. If it's fair, then I'm going to get a heads half the time, but maybe not half the time if I only flip it 6 times. So if I only flip it 6 times, I could get heads, heads, tails, tails, heads, tails. That's half the time. I could get a totally different, right? I could get a bunch of tails at once, right? That would be a possibility. So in the short run, I have really no way of saying or accusing this coin of being unfair. When I say fair, what I mean is that if I flipped it many, many times, the proportion of heads would be approximately 1/2, and this proportion would tend to get closer and closer to 1/2 as I increase the number of tosses. Wow. Okay, I didn't even read the other ones, but my eyes kind of gravitated to this word many, many. Now, if it was a high stakes test, I would read the other ones, but this one's definitely my right answer. Thanks for joining us. Yeah.